In this video, I'll be covering the ladder logic for the punching machine. As you can see, the punching machine will need a separate push button to start. Already all the inputs from I1 till 4, they are used, therefore I'll need a separate push button which is I5 to start the machine. When you place the item here, this item, when you place it here and press I5, it is expected that the machine will go forward, which is Q1, and when it reaches I2, it will eventually stop and call output Q3, which is the downward motion, and the downward motion will come and press the workpiece and also be in contact with I3. Then I3 will therefore release a signal for I4 to go back up. When it reaches to I4 again, it will go backward until I1. Then you will be allowed to take the workpiece. Then there's another important section that I need to make sure. The machine is currently at I4. I4 is pressed. Whenever I program, I need to make sure that I remember that fact. Okay? So when you click on new, we have two options on this drop down box. I have two options, the function block and ladder. As I have said earlier, we are doing the ladder logic. So there are two items that you need to always place. Okay, where as soon as you place I1, there will be this box. You can just press escape for now, and then you place I1 again, press escape and place the brake, press escape and place the coil. Okay, this coil is for the forward motion, which is FR motor. Okay, you don't press enter at this point whenever you are making comments. Okay, and then this one needs to be the memory coil for the motor. So it's gonna be like that. So when this motor is running, this coil is running. Okay, and then this one must be our I5 to start the machine. Start. Okay, perfect. Then this one must be our I2. When it reaches I2, we are expected for it to eventually stop. Okay, let's see if it will really simulate that. In this video, we are only simulating. We are not running the online test of the real machine. So now this needs to change to be a push button, momentary push button, preferably. So that when I press only once, I can depress the push button. This one I'll leave it as a switch. Okay, so now when I press it, the whole system switches off, and I need to unpress it again so that the system can switch on again. So now you can see that the motor runs until I2. Okay, which is okay. So press escape to be able to edit again, and we do the very same procedure. Press escape, put another input. This input is going to be I2. Press escape. Fortunately that just came up, I don't need it. And then press put brake. This brake is going to I2 according to this diagram. It is expected to bring down the motor with Q3. So it's going to until I3. Okay, so we are activating Q3 and we're going to stop at I3. Press escape every time, even for no reason. So this one is a downward motion, which is my Q. Okay, I'm putting a lot of things now. This one will move. This one, I can just move it down also because I'll need it. It's fine. Pardon that mistake. So now this one is down. It's down motor. Okay, These are my abbreviation to make my life easily. Labeling is very important in the PLC, so you need to always label. Okay, now this must be the representation of the Q3. Perfect. So now we are saying that this is connected like that, like this. Okay, I'm making a mistake there. That, and this is connected there, and this is connected there. Perfect. So now, okay, and we need to face facts before anything else. When I press I5, I2, the current state at I2 is connected, but it's not pressed. Get that right. Now I'm pressing I2. I'm stopping at I2. Where is our item currently? It's at I2. It has stopped there, so that Q3 can be activated. Okay, so as Q3 is being activated, the motor goes down until I3. And keep in mind, I2 is still activated. I2 that called Q3 initially is still activated, meaning that it will still call Q3. In the next step, I am going to show you how is it going to call Q3. I'm going to skip a line there. This one, okay, this one I believe should be I3 for upward motion, and I need a break of I4 there, because now we're going back to I4. Okay, so now this must connect there, that must be there, and this must go there. Okay, this must go there. Okay, and this must go there. Alright, if you're confused, you can watch the other video I made on different types of latching or retaining circuits on ladder, so that you don't wonder what the hell am I doing, so that you can keep up. I have my email on the description section, so that if you want this software for your own good or for your own use, you could be able to get in touch with you and forward you their software. I now want to recruit a lot of people to join me into this thing of programming in PLC. This is just a basic PLC, nothing serious, but the knowledge you will gather here will let you go a long way with programming. So this is a Q4. Okay, perfect. So now I want to see the I2 in action. And we go to I2. Then we're at I2. We have depressed I2. Motor goes down until I3, and motor reaches I4. Reaches I3. Then it must go up. As it goes up, immediately it depresses. It depresses I3. Then motor down starts to activate because of I2. Then we need a temporary signal to go to I2. How do we then create a temporary signal? We create a temporary signal by, okay, that just wanted to be there. So this is going to be I2, and I need an AND edge that triggers the signal only once. AND edge, like that, like that. So now the signal here at AND edge must be dedicated at I2. I'm removing I2 because he's becoming a stumbling block to my program. So now validation is key in programming. So now you see this AND edge is now represented there. And the function of iron edge is simple. It will always give us one single signal, only once. Let's observe. I5, motor go forward, it reaches I2, it stops at I2. Keep that in mind, and it goes down. Look at the signal that was going to I2. It's no longer there, but the motor managed to went down. Now we want the motor to go where? To go up until I4. And when it reaches I4, it needs to activate the backward motion. Very critical. Okay, well, perfectly. Can't I just copy everything like this, like that? Copy paste. Take them down. Everything like that, as it is. Change this to be Q2. Change this to be I1. I1. Change this to be this is a start I4. Perfect. And then after that, connect everything. Connect everything. Connect everything. So now this is the backward motion. Backward motion. BK motor. Do not press OK when you are commenting. Do like that. Okay, perfect. So now it's testing time. I4 is pressed. Look at what happens at Q2. Q2 is being activated. I4 is pressed. Q2 going backward is activated. Even before we even start our process, Q1 and Q2 are both pressed. We need to create a signal called the preliminary latch, which we set a condition, and that condition needs to be met before I4 can release a signal here sending the motor backward. All right, so how do we design that as a temporary signal? Let me close here. These I hardly use them. Maybe these ones I might not use, hopefully. Okay, how do I design that? So I'll design that system with I3 and with I1 also. Perfect. Okay, it keeps on placing things that I don't need. Escape, all right. Okay, escape, delete this, escape again. I need a latch, put a latch there. Latch, don't go far. All right, so now when I3 is connected, look at this. When I3 is active, it will hold a signal at a latch relay. When that signal is on, we can therefore allow I4 to pass that signal there at here to activate the motor going backward. So how do we then do that? I'm going to pull this away, pull this a little bit, and then I'm going to put that signal from I3 on using the latching relay. I'm going to bring it closer like this one. You see now? So now we are having a series connection there. So before we can go there, it means that I3 must be on, right? So now let's see our process if it will really work. That, okay, switch off anything that you don't really need for now, and For the matter of fact, I4 is currently on alone. So this is I4 is on. Look at now, I4 is no longer able to switch on the backward motion. You see now we have an end here that will be activated by I3. So now it means that in short, the item needs to start moving there and go to I2. I2 activates a downward motion, and only when I3 is on, it has a temporary signal that it created, and then when it reaches I4, those two signals, when they're combined, they will therefore release the backward motion. Simple. Okay, so now we then start our process. The motor is running smoothly to I2. I2 is pressed and it is held there. Then it activates the downward motion. The downward motion goes down until I3. You see that? It goes down until I3. There's something that you need to appreciate. As it was going down, I need to emphasize this. As it was going down, this was deactivated. Look at here. Let me deactivate there. Let me deactivate this. As it was going down to I3, as it was going down, it moved away from I4. Look at that. It moved away from I4. And then as it moves away from I4, it therefore gets to I3. When I3 is on, then the upward motion is now activated. And then it will go up until I4. Until I4. Look at this. Okay. My I1 is active, so that is causing me problems. Alright, let me start afresh because I bet I might have made a huge mistake. I4 must be the only person who's on, and I2, yeah. So now these are the inverse. So when you press them, it means they are off basically. Don't be shy. Let me just deactivate, activate anything that needs to be deactivated. Okay, so I think everything is off. I4 is the only one is on. Okay, let me just do it one more time. I5 is on, and the motor runs until I2 is on. It goes down. As it goes down, immediately as it goes down, before it reaches I4, I3, I4 is being deactivated. You need to keep that in mind. I4 is deactivated. What do I mean? We're moving away from I4 to I3. Therefore, I4 is deactivated. And then we're going to reach I3 and create a preliminary latch. We will reach I3 and create a preliminary latch. Now we're going up. Q4 is activated. Look at this. Q4 is activated. And this needs to be unpressed again. You see that? Q4 is activated. It goes up until I4 here. When I4 and this signal, look at this signal, the signal that is represented here, when it matches with the now signal, the current signal at I4, when they both match, our motor Q2 is able to send the product back to I1. It's gonna move until I1, and when it reaches I1, it will deactivate this signal here and also deactivates this motor there. And then it gives you the chance to pick your item and to place another one and to press the I2 the start button again. So this one will be left activated. So now when you do it again, Q1 runs until I2 is being pressed. When I2 is pressed, motor goes down. Remember, I4 needs to be released and I1 there needs to be released. It goes down until I3. Look at this. When I3 is pressed, Q up, the machine goes up until I4. When it gets to I4, the motor backward is being activated. It goes until I1. And then you would, this I3 is deactivated. You would therefore remove the part. As we remove the part, it deactivates that latch here, and our program is complete. The punching machine program using ladder logic is completed. Thank you so much for your support. Don't be shy to leave any comment, to like if you are happy with the video, and to subscribe if you want more of this type of content. And if you are willing to practice, I can organize the software for you, and you will download it and you will try to follow my videos on your own time. Thank you so much for your support and for your time.